All right. So thanks everybody for being here. My name is Simon. I worked at Octo Technology as a data scientist and a data architect. Octo is a consulting firm based in Paris. We do a lot of things. One of them is big data consultancy. And the reason why I'm having this session today is because I think that we address the big data paradigm too much with technology and not enough with other key components such as culture, organization, and methodology. So I'm going to talk about that today. I'll start with a simple story. Datadriven Commerce we worked for in France. So basically, they have this payment process that is very capital because it's an e-commerce, and they offer their customers to pay in multiple times, so 3 times payment. So of course, this is very great because it's maximizing the sales, but at the same time, some people, they never pay, so they have to recover the money, hire lawyers, specific institution, and so on. So we build an algorithm to predict if the client is actually going to pay or not. And we estimated the savings from 1 to 2 million euros every year. So this is exactly what it means to be data-driven, is to use data and data science to generate return on investment. And you are really data-driven if you are able to measure it. So to me, being data-driven, it means a continuous improvement of all business processes through smart use of the data all the time, everywhere, and to all purposes. So to me, this is basically just mean to be lean, as lean startup. So you have data, you have ideas against the data, new use cases you want to try. You build software for that, data science code, and you test it, and you have new data, and it's a virtual circle. So I'm going to build this presentation on these 3 elements: IDs, data, and code, and what are the requirements if you want to be data-driven. So for IDs, the goal is to have the business, people from the business, aware of opportunities to use algorithms. And this is not something easy, because if you don't have the culture of data, statistics, machine learning, you don't always realize that there is an opportunity to use data science to improve certain processes. The second requirement is about data. Data must be easily accessible. It may sound very stupid, but it's actually kind of difficult. And I've been in many projects, and most of the time this is not the case, okay? And the last one is pretty simple also. Data science projects, they should have the lowest time to market possible. Okay, let's start with data. The data must be really easily accessible. And the thing I want to say today is that your data lake or your data warehouse, whatever it is, it should be a service to your company. It should be managed like a startup in the sense that your employees are your first clients. The more they use it, the more you are data-driven. And we focus too much on technologies. We focus too much on things such as high availability or security or stuff like that. I see some IT departments, they build offers for their business lines, and they build things like, okay, hash-based cluster on demand on virtual machines, but we don't care about that. So you need really to build a data lake team which is made of operations, developers, and even designers, people that actually design the experience to interact with the data lake. So the goal of this team is really gather requirements and usage metrics how the projects and the data science projects actually use the data lake, and they need to grant support for these projects. Let me give some examples. If you want to focus on usability over architecture, you have to ask questions like, how simple is it to share data to other projects? Actually, this is sometimes really difficult to do. Yesterday, we had a talk by Spotify, and at the end of the presentation, there was a question about security. And they asked if what they built as an architecture was compliant with Kerberos. And the guy answered, oh, no, we don't have Kerberos. And pretty much everybody accesses to the data in the data lake. And I was like, yeah, this is amazing. This is some political choice, okay? You want to focus over architecture or you want to focus over usability? And I really liked what that guy said. I was almost crying. I was saying, yeah, okay, fuck security, we just want usability. And it can be very simple. I mean, it can be just data governance. If you want to share data between projects, you can say something as, okay, every project has a directory on HDFS, and every project has a subdirectory that is called dash public. And when you publish data to this dash public directory, everybody has read access on it. It can be as simple as that, but you have to design these services to enable and foster innovation within the data lake. How simple is it to subscribe to a data feed? This is some things that we were used to do in our everyday life. It is sharing stuff, subscribing to a Twitter feed. The next functionality is full search, so it's just a Google search. All these functionalities, they enable you to really interact with the data, so it should be simple. Full search on a data lake, that is not something that is made. I've seen it really rarely in the companies I'm consulting in. And still, this is something really important. If I'm a data scientist, I work on a new project, I want to access financial data, for example, in my company, or data from human resources. How do I know where is the data located? In which system? In which front-end application? I have to know the people that are working into the IT. I have to ask a lot of questions. I have to send mails. It should be in a search engine. It should be easily accessible. Is it possible to ask other projects for details about their data through a social network? I really want to show you that you also need to think about how the projects are going to work together. So typically, it could be just a Slack channel, or it could be a forum or mailing list, anything. But I just want to be able to reach other projects and talk about the data through a single channel. That is the channel for the people that uses the data lake. Auto-completion of our SQL requests from other projects to have insights and recommendations, bookmarking, sharing, upvoting data sets, tagging metadata, all these things, they are about usability. And it's really going to help you if you want to be in a company where you have a lot of use cases and data is easily accessible. Okay, code. So here the idea is to have the lowest time to market possible for your data science applications. And this is quite complicated because on one side, you have to explore as quickly as possible because maybe there is absolutely no signal in the data and you're going to try some models and it's not going to work because, I don't know, you are trying to predict the stock market and it's nearly impossible. If it is, contact me. And at the same time, you want to deliver frequently in production because if you let some people, statisticians, work on IPython, on R for 6 months without delivering on production, when it's going to come the time that you want to deploy in production, you're going to have a bad time because the code is going to be dirty, it's going to be very poorly performing. It's going to be a one-shot exploration code. So you have these two aspects that you need to balance. So for the first one, what I want to say is we got to stop a little bit from all these big data solutions that we see everywhere. Okay, Storm, Spark, NiFi, Flink, Samza, and all these things. If you look at how our data science team is working, they use Python and RStudio for most of the time. Because these tools are mature, they have the right technology to do what a data scientist needs to do. They are interactive. That means that you have the data in memory. If you want to plot something, it's immediate. If you want to compute a new column to retrain your algorithm, it's immediate. So you can't be fast during the exploration if you don't use that. You can't be fast during the exploration if you use distributed computing with complex APIs and so on. So just give them this kind of environment with simple tools and give them infrastructure with a lot of memory. Could be just their own laptop. It could be a big server with a lot of RAM. I don't really care. Just give them the space to explore really quickly with those tools. And do not force them to use big data distributed computing solutions. And I want to say also, this is a slide from a presentation last year. In some cases, undersampling is perfectly fine, okay? In some cases, if you train your algorithm against less data, it's okay, you have only few differences in the final model. And to explore data, maybe you will train the model on all the data, but for the exploration, for the POC, you need to go fast, you subsample the data, you work in memory with the tools that you know the most, and it's gone. So the other aspect is being ready for production and delivering production frequently. So for that, the best recommendation that I have, and this is really the main recommendation of the whole presentation, is to build feature teams, okay? Because data science, we all know this chart on the left. Data science needs hacking skills, so programmers' skills, math, and substances expertise. People that know all the business, run what are the main losses and the main sources of revenues in the company and so on. So if you want to have all these skills, you simply put a team that gathers the skills, okay? So you put in the same room developers, business, people from the business, and data scientists. And you really make an agile team with that. They have stand-up meetings, they do retros, they do refactoring together, they are in the same room, okay? And this way, for example, typically, if you have a developer or guys from the operations, they are going to control the code quality from the data scientist. They are going to think about what is going to happen when you push to production. They are going to refactor things and so on. So this is really helping to still go quickly during the exploration, but have a controlled quality through it. Another great pattern that is more about architecture is to use message brokers to reuse the data flows. So on the left side, you have an information system that is point-to-point integration. So you have every application that is communicating with all the other applications. On the right side, you have an information system that is built with an enterprise bus. So this is not new. This is something that is already out for 20 years, I mean. But the idea is that if you have a new application, well, typically a data science application, a new project coming in, on the left side, you will have to find the teams for every application, talk to them, talk about the data formats, talk about scheduling, the freshness of the data that you want, the SLAs that the application is giving you. You need to make custom development to integrate the data, and all these things. And when you want to go from exploration to production, you're going to have to think about all these things again, because maybe you just ask for a big CSV file that is a dump of the database just to do the exploration, and once you want to go to production, then you have to maybe subscribe to a GMS channel, and this is another data format, and you have to do all the things again. On the right side, you have a standard format. That is the format that is on the bus, because you said, oh, okay, this bus here, everything is Avro in it, okay? So you know how to read it because this is a standard enterprise format. You have the libraries to do that. The bus is production ready because there is a team that is maintaining it. They already thought about the SLAs, high availability, and all these things. And the exploration and production will share the exact same format. So there is no effort to put when you want to deploy in production because you did the exploration on the format that is on the bus, and when you want to go to the production, it's the same data. A good pattern that is a great combination with that message broker thing is the K-PA architecture, where you just think as every processing as a streaming application. So basically, if you compare that to the Lambda architecture, you just think that a batch job, for example, is just historical data that you send in a streaming app. So the application code is kind of decoupled from technical requirements. You code everything as a streaming app. At the end, if you want low latency, you have it. If you don't want low latency, you want to do it as a batch, you schedule it to run every month or so. You really decouple those things. So you can explore the data without technical requirements, because you just want to do a POC and validate that there is signal in the data. And once you want to go to production and that you have technical requirements, this is OK, because you did everything to process stream data. OK. The last part is about IDs and how do you generate new business cases. And the requirement is that this business must be aware of the opportunities to use algorithms. So this might be the most complex part because this is about people. The key thing is that guys from the business, they knows what is really valuable, but data scientists, maybe they don't know the business too much and they know what is feasible. So you got to combine these guys and these people together so they can share a common culture about what is data science, what is machine learning, and so on. And they need to collaborate. So to do that, again, the best recommendation is to have a feature team with all these people in the same room. They have rituals, they have stand-up meetings. They can have other rituals for the data to share a culture of data. I like the 10-minute rules, for example. This is a great ritual for meetings. It's a rule that says that you cannot talk during the meeting before everybody has read the data during 10 minutes. So you sit down, you take the dashboards, you look at the data, you don't talk, and after 10 minutes, everybody can speak. So it's this kind of rituals that will bring you new habits and new understanding of what is data science and how you work with data. The other thing is to explain people from the business that machine learning is easy in the sense that it's methodology. These are just 4 lines of Python scikit-learn. So I just wanted to show that sometimes we think that machine learning is a complex mathematical thing, but in the end, all the complexity is hidden in libraries, OK? So to me, as a data scientist, I think my work is mainly about methodology. To define the problem, to define the target, to define if it is classification or regression, how do I validate the model? What is the metric to validate the model? And so on and so on. So I think nowadays, the role of a data scientist is mainly methodology, and methodology can be explained to people that are non-scientific. This is something that they can really understand, and I've done it in the past in multiple projects. They can get that methodology of training, training set, testing set, cross-validation, and all these things, they can understand it. So you have to explain them that. The second thing to tell the business so they have business ideas is machine learning is easy in the sense that it's kind of magic, OK? Before you start a use case, you never know if it's going to work or not. Maybe you can predict if there is a dog or a cat in the picture, maybe you can't. Maybe you can predict the stock market, maybe you can't. I don't know, but if I don't try, I can say. And this is pretty fast, actually, to train a machine learning algorithm, OK? When you start a new Kaggle competition, for example, you can get bootstrapped in 2 or 3 hours. So they need to understand that this is easy to build models nowadays. This is not something that is an R&D project for 2 years, OK? And they also need to understand that there is a little bit of magic in machine learning. So this is something that I often say during workshops with people from the business, so they have new ideas for use cases. I say to them, OK, you have a magic wand. What do you do with it? And for example, the people from the e-commerce, if you don't say that, they won't have the idea to say, OK, maybe I could predict if the customer is going to pay or not. If you say that they can do whatever they want to do, maybe they are going to have this idea. So they really need to understand that you can go really quick when you do machine learning. Again, you need to mix those people. So you got to spend time together. So feature teams, you show them the data. Actually, I see very few people do that, but you can do pair programming. You take someone from the business, sit down next to you. You go on IPython. You do the dashboards. You ask them questions. They ask you new questions. You compute models in real time with them. You show them the data, and this way they are going to realize that your job is quite quick. Is quite easy to train a model, and they will have this reflex to have new business ideas and business cases for machine learning. And also a great tip is swapping roles for one day. So this is really amazing. Basically, the idea is that you take a data scientist and the guy follows someone from the business for a whole day. So he can see what are the main decisions that they have to take, what are the main problems that they are facing, what are the processes, the main customer journeys that the company is having, and so on. And the opposite is also true. You have them working with you so they can see that what is actually machine learning. Okay. Last, I'm pushing it a bit, but software is eating the world, so you can maybe make them code, okay? So yeah, make code people from the business. I know this is a bit weird, but 400 years ago, we were saying that reading is not for everybody. You don't need to know how to read. This is just for people from the highest classes. And yeah, this is maybe the same with code, okay? We say this is something just for developers, but nowadays, the simplest way to go from an idea to this reality is coding it, okay? This is why we have all this momentum about startups and so on. So maybe just think about that and get technical with business people. It's okay to do that. And I'm finishing with a story. So this is a product that we launched at my company, Octo. Basically, the idea is to set up a data science competition platform within company. So we install it, we scope use cases with the company, and we run competitions just like Kaggle. And they have really the opportunity to share a common understanding of what is machine learning company-wise. So you have people from the business that show the challenges that are on the platform, that they can see the solutions that data scientists proposed. And this way you have kind of a momentum and a great event where everybody gets to understand specifically for their business what it means to do machine learning. So it's kind of great, and it's really building gamification and engagement for everybody. Just some KPIs to measure if you are data-driven currently. So you are data-driven widely if everybody is willing to make value out of the available data. And when I say everybody, it's everybody from the business, from human resources, accountants, everybody, guys from the operations. Data serves not only the core business, but every single function, so as I said. And data is used in day-to-day activity in real time. So it's not just something for yearly evaluations or some stuff like that. And you are deeply data-driven if you're using cutting-edge algorithms to automate processes. So it's about doing ensemble learning, doing maybe deep learning, doing online learning with cutting-edge frameworks such as Rabbit or this kind of stuff. You are used to do A/B testing based on data every week, and you cross multiple data sources to build inside the models. So not just sources that are relevant to a problem, but also weird other sources that could be useful. So I really think that we have to think of all these things when it comes to big data. I'm going to make a terrible comparison, but a few decades ago, we had agile methodologies. Agile methodologies has nothing to do with technology, okay? They are just about culture, organization, and methodology, and still, they are very, very powerful and efficient. They really change the way we deliver software. So we got to think about that for the big data movement. And if we don't, I think there will be a lot of disappointment about big data. So focus on great usability on the data lake, build feature teams, and share this understanding of what is data science in your company. Thanks. Any questions?
then more use case after more data was ingested, or more use case were requiring more data?
When you are doing machine learning, there is a kind of curve where you have an accuracy, and the more you have data, of course, the best your model is. But this curve is going this way. I mean, if you have 1, 2 data sources, you get a pretty good model, and the more you add, and the less your model is going to improve. So I think this is the answer. You need to go for a fail fast, to have a strong enough model, to put it in production, and more data it will be for later if you really think this is an important topic, and you need really the percentage to get. No questions? Thank you.